In this video we're going to look at the topic inequalities, and the first thing we're going to do is have a look at number lines and how inequalities are represented on number lines. In the first one we've got x is greater than -1. So -1 is our sort of reference point. Because it's a greater than sign and not a greater than equals to, we can just put a hollow circle around -1 to say that we get very close to -1, but it's not equal to -1. And it's greater than, and greater than is to the right. So we just put an arrow like that. And the second one, we've got an upper and a lower limit. So reading this, x is less than or equal to 3, so that means we put a coloured in circle because 3 is included this time. And reading this, you can read it one of two ways. X is greater than -2, or -2 is less than x. It's up to you. In which case -2 is not included, so it gets a hollow circle, and x is all the values that are between these, so we're talking about these. Okay, so now we go on to simplifying some equations. So we've got a set of brackets we need to expand here. So we have 4x take 1 is less than 5x plus 10. Now we can collect all our variables on one side, the other, that sort of thing. Because there's 5x is greater than 4x, not because of what's written, I'm going to collect all my x's on this side and all my numbers on this side. So 5x take away 4x is just x, and -1 minus 10 is -11. That's a little bit clumsy from a reading point of view, so that needs to be reversed, and we can say that x is less than -11. So moving on to the next one. Now this one's a compound inequality, so we need to consider 5x minus 2 being less than x plus 6, and we need to consider x plus 6 is less than or equal to 12 plus 7x. Then we need to solve both of these. So solving the left-hand side one, so collecting my x's and doing the subtraction, so 5x take away x is 4x, is less than, putting the -2 over makes 8, so x is less than 2. Now there's no problem with that. Now with this one, I'm going to collect this time my x terms on the left-hand side, so x take away 7x is -6x, is less than or equal to 12 take away 6, which is 6. Now we're going to divide both sides by -6. We need to remember the rule that when you multiply or divide by a negative, that you need to change the inequality sign. Okay, so these need to be combined. So we can draw a little number line. Two major points are 2 and -1. X has to be greater than or equal to -1, so that one gets coloured in. But x is only less than 2, so that's hollow. And we're talking about the parts in between. The other way that we can do this is to put these together in an inequality. So we can say that x is less than 2 So x is greater than or equal to -1. And just an example of how we can graph an inequality. What I'm going to do is this can be rewritten as y is less than -3x plus 9, and that's in the form of y equals mx plus c, or y equals -3x plus 9. What we're going to do is consider that line, but then we're going to take into account the less than. So, just setting up a quick set of axes here. Very quickly working out our intercepts and the like. We know that the y-intercept occurs when x equals 0. So when x equals 0, y equals 9. So we have the point 0, 9. And the x-intercept occurs when y equals 0. So 3x will equal 9. So x will equal 3. Okay, let's just double check that. So when x is equal to 3, minus 3 times 3 plus 9 does equal 0. Good. So that means that the line that we're talking about goes through those points. But if we look at our inequality, x is less than that. So we only need this line as a guide, so we put it in as a dashed line. Now, if we had y is equal to or less than, then we would put in a solid line because that would be included as part of the solution. Now, y is less than -3x plus 9 means that we need to shade one side or the other. And that's often a little bit difficult to work out. So if we have a look here, the origin, 0, 0, is distinctly in one part of the graph. So what we can do is we can use that point, 0, 0, to check whether this is true. So using 0, 0, is 0 less than -3 times 0 plus 9? Is 0 less than 9? And the answer is yes, that's true. So that means that the origin must be one of the solutions. So this side of the line must be the solution set.